we are given a CNF, actually a 3 CNF, consisting of 5 clauses. And the question is if this CNF, or we can say this set of those 5 clauses, is satisfiable. What does it mean? Well, we have to find an interpretation which makes all the 5 clauses true at the same time. And basically, the algorithm we have to use now, called DPLL, is about finding such an interpretation. You can see the pseudocode of this algorithm here. On the right-hand side, this is basically implemented as a procedure. This procedure takes 2 parameters, the closed set itself. So this is going to be the closed set of those 5 clauses. And it takes an interpretation, which is the current interpretation. This interpretation will be constructed on the fly, step by step, by us. So at the beginning, this interpretation is empty. This is an empty set, or we can also denote it like that. So it has no elements yet. But step by step, we will extend this interpretation in new elements. Okay, so let's run the algorithm. Let's start with the first step, unit propagation. Are there any units in our closed set? No, there are no units, so we cannot apply this step right now. What is the next step? Can we tell if any of the 5 clauses is already false over the interpretation? No, because in my interpretation is still empty. In a similar manner, I cannot say any of the clauses, if any of the clauses is true or 1. Therefore, we can only apply step number 4, decision. What is this step about? We have to pick one of the variables. Notice that we have 5 variables in the formula: x1, x2, x3, x4, and x5. So we have to pick any of them. It's completely up to us. And then we have to assign this variable to true at the first time. We register this decision by adding the variable to the interpretation. Let's pick x1 now. So we add x1 to the interpretation, meaning that we assigned the truth value true or 1 to this variable. And how to continue? Well, as you can see, now we call the DPLL procedure, the procedure we are inside. So this is actually a recursive procedure call for this DPLL procedure. So we restart the procedure with unit propagation. Still, there are no units in the closed set, even if we have something in the interpretation. So we cannot apply the first step. We cannot apply the second and the third steps either, because over this interpretation, we cannot specify the truth value of any of the 5 clauses yet. So again, we have to make a decision. We have to pick a variable. Let's pick x2 in this case and assign it to true. And again, we recursively call the DPLL procedure. So we start at the beginning. Now, let's check out if we have any unit in the closed set over this interpretation. And actually, yes, we have. Let's look at the second clause. Well, in the second clause, these 2 literals are false because of the interpretation. Remember, x1 and x2 are assigned to true. Therefore, if you negate them, both of them are 0. Therefore, if we want to make this clause true, we must assign 1 to x4. So x4 is a unit over this interpretation. Therefore, as the first step in the algorithm says we have to add this unit to the interpretation. Yeah, and we have to add all the units, you see, all the units. So let's check out if we have further units in the closed set. Yes, we have one here at the very beginning. Not x2 is 0, not x4 is 0, therefore x3 must be assigned to true. So we add x3 to the interpretation. Yeah, and in a similar way, we can add another unit. Not x1 is false, not x3 is false, therefore x5 must be true. We add x5 to the interpretation. Of course, we cannot extend the interpretation further, so we can check now if there is any falsified clause in the closed set, and unfortunately, yes, we have a falsified clause in the closed set. Which one? Can you find it? Okay, for instance, this one. All the literals are false, therefore this clause is false, which is not okay. We have to satisfy the closed set. So in step number 2, if we notice that any of the clauses is falsified, we have to return to the previous procedure call, so to this point actually. So let me just clean the screen a little bit. So we return to this point, and actually, since we were executing this point, we added 3 unit clauses. So we have to erase them as well. And we have to erase we don't have to erase, we have to negate the very last decided literal, because this is what you can see in step 4b here. So basically, we try what happens if x2 is assigned to false this time, because when it was assigned to true, it didn't work. So now we assign false to the same variable. Okay, so again, recursive procedure call happens. So we restart running the steps. And now let's see if we can apply any unit propagation. We cannot falsify clauses. We cannot make all the clauses true. Therefore, we have to pick a variable and assign it to true. Let's pick x3, assign it to true, and make a recursive call again. And let's see if we can find any units after that. Units, maybe we can. Let's see. Yes, we can actually. We can stop the algorithm because all the clauses seem to be true. Why is that? First of all, in the first clause, x1 is assigned to 1. So this makes the entire first clause true. In the second clause, not x1 is true. This makes the entire second clause true. In a similar fashion, the third clause is true, and the very last clause is true. And finally, oh, okay. And yeah, before that, we should have propagate the unit x5. By doing so, this clause is also satisfied. So this is the result of the DPL algorithm over this closed set. We found an interpretation here. Actually, algorithm generated an algorithm interpretation for us, which makes all the clauses in the closed set satisfiable. You could see that this algorithm consists of well-defined steps. You just need to execute them one by one. And you also saw that there are 2 steps which make recursive calls to the procedure. And sometimes along the chain of those recursive calls, we have to return to a previous recursive call and try to execute everything in another direction. Finally, if everything works out, we can find an interpretation like this time, and this is how we can prove that the closed set is satisfiable.